All right, now that you've finished your book of exponents, you need to find your note packet. This is section 2, day 1, and you need to find page 5. Page 5. So while you're looking for that, let's go back here. You just wrote about these 3 multiplication rules. We're going to focus on this second one today. And I want to remind you again that when we are dealing with exponents, remember the exponent is the small number. It's the power it's the amount of times we are going to be multiplying. So in this example, 4 to the third, 4 is the base. The 3 means multiply 4 to it by itself 3 times. So this first rule is called product of powers. We are doing the product, which remember means multiplication, of powers. So if you look at example 1, we have 12 to the third times 12 to the fourth. So what I want to first show you is if I take 12 to the third and I expand it out, what I mean by that is there are 3 12s. So that's the same as 12 times 12 times 12. Okay, that's what 12 to the third is. Well, I'm going to multiply again by 12 to the fourth. So I can do the same thing over here. I have 4 sets of 12. So 12 times 12 times 12 times 12. Well, if I look at it, I have a lot of 12s here. I have 1, 2, 3, 4, 5, 6, 7 12s. So I have 7 12s. So when I compress that all back together, isn't that the same as 12 to the 7th power? And another way I can do that, if we come down here, that we wrote about as far as you can call these shortcuts, I guess. But the shortcuts exist because this is really what is happening when you combine them. When I am multiplying the same base, x and x are the same base, it's the same as simply adding those powers. So let's look at it another way. If I do 12 to the third times 12 to the fourth, here is the multiplication. That's the same as 12 to the 3 plus 4 power. And when I do the math, 3 plus 4 is 7. So 12 to the 7th. And so notice I get 12 to the 7th here. So the shortcut is to recognize when you're multiplying the same base, you can simply add your powers together. Or really what we're doing is we're very quickly expanding it out and then bringing it all back together. So let's do that one more time on example 2, and then we'll just stick to following the rule. So j to the fourth, if I write that out, is the same as j times j times j times j, right? There are 4 of them. Now I have 2 more, so I have to multiply, by j times j. So when I count them up, I have 1, 2, 3, 4, 5, 6. That would be j to the 6th power. Or j to the fourth times j to the second is equal to j to the 4 plus 2 power, and I know that 4 plus 2 is 6. So again, here are my answers that are the same. So I really want you to understand where the shortcut comes from, because if you don't understand that, then you will get confused when we add another element to this. So on the summary section, I'm going to bring your book back in here. What I'd like you to write is let's use this same example in our book. Let's write x to the second times x to the third. And I want you to write equals x to the 2 plus 3 power. So let's write this sentence out here. When multiplying powers that are the same base, when multiplying powers with the same base, when multiplying powers with the same base, and in parentheses I'd like you to put x because that represents the x in our example. So when multiplying powers with the same base, x in this case, add exponents. You simply add the exponents together, which is and in parentheses I want you to write 2 plus 3. So if you need to come back here, you can at least kind of go back and look at what did you write and how does that situation apply to your new problem. All right, so I would like you to try these 4 right here. You can try it by expanding it out like we did here and bringing it back together. you can try it with the shortcut, but do one of those two methods. So go ahead and pause it. I'd like you to try it, and then we'll come back and we'll explain it. Okay, so go ahead and pause now. Okay, let's check your work here. R to the 18th times R to the 3rd. I recognize multiplication here. So I can just do R to the 18 plus 3 power. And when I do 18 plus 3, I get 21. So when I simplify this, I get R to the 21st power. Number 2, I notice I have an E and I have a W. It's not the same as like R and R. So these cannot be simplified. So I'm just going to write, E to the 5th times W to the 8th. And that is as simplified as I can go. Number 3, x to the 4th plus x to the 7th. Well, I see a plus sign here. I'm not even multiplying. This only occurs when you multiply things together. So when I look at that, the only thing I maybe could do, are those like terms? Can I add them together? No, one is a 4th power, one is a 7th. So this is a little bit like what we just did. It cannot change. So it is already simplified. Number 4, I see h and h, I see multiplication. So I can do h to the 512 plus 6 power, and 512 plus 6 is 518. Okay. All right, let's move on and let's look at several more together. And I'm going to encourage you to write together what you can actually add until you get the hang of it. So when I see this big long problem, f to the 4th times h to the 7th times w squared times f to the 6th, h to the negative 3rd, w to the 5th. I have a multiplication sign here, but don't I simply have multiplication between all of these? So for right now, I'm just going to add a dot in between all of these. There's no difference. It's just 1, 2, 3, 4, 5, 6 things being multiplied together. So I want to really group together things that are similar. I see f a couple of times. So I have f to the 4th times f to the 6th. So f to the 4th times f to the 6th is really f to the 4 plus 6 power, which is f to the 10th. So I have f to the 10th. I see an h and an h. So h to the 7th times h to the negative 3rd is h to the 7 plus negative 3. Well, what is 7 plus negative 3? 7 plus negative 3 is equal to 4. So that's really h to the 4th. So I have f to the 10th times h to the 4th. And then here's w and w. So I have w to the 2nd times w to the 5th. That's w to the 2 plus 5, w to the 7th. Final solution. Okay. All right. Oops. Number 2. Verify its multiplication. Yes. Times, 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 times. So I'm going to look at d with d. So d to the 7 plus 3, that's d to the 10th. So I have d to the 10th, s's and s's. So that's going to be s to the negative 4 plus 11. So negative 4 plus 11, I'm really subtracting those. That's going to be 7. So d to the 10th times s to the 7th. Notice nothing goes with y. It travels to my answer. Okay. All right, number 3. A little bit different. I have variables. I have coefficients in front of my variables. But remember, when you have a coefficient in front of an x, it's multiplication. So this is, again, just 4 times x to the 8th times 7 times x to the 12th. So I can rearrange all this, and I can write it like this. 4 times 7 times x to the 8th times x to the 12th. Well, can I do 4 times 7? Yeah, I can. 4 times 7 is 28. And remember, when I do x to the 8th, you're really doing x to the 8 plus 12. So 8 plus 12 is 20. So it's x to the 20th power. So when you have numbers, you're multiplying. So we know how to multiply numbers. We'll multiply those together. Okay, number 4. I have numbers. Remember, all multiplication here, all times. If you want to add those dots to reinforce that, please do so. 18 times 11. So let's do 18 times 11, and I have 198. So 198. So I have J and J. So I'm going to, until you get really good at this, I want you to write down what you're doing, what you're adding. I'm doing J to the 7th plus negative 1. So what is 7 plus negative 1? Well, 7 plus negative 1 is 6. So that's J to the 6th. K and K. So I'm really doing K to the negative 5 plus 62. So negative 5 plus 62, I can really do 62 minus 5. So what is that? 61, 60, 59, 58, 57. So that's going to be K to the 57th power. That is my solution. All right, I want you to try 5 and 6. And if you really feel like you're on a roll, you can keep going. So pause the video as long as you feel comfortable and then come back. I'll work them out. Okay, so for sure try 5 and 6 on your own. Give yourself a few minutes and then come back and check the solutions. Okay, let me work number 5 with you. Number 5, I see the two numbers, 8 times 7. That's 56. M and M. So I'm doing M, negative 2 plus 5. Negative 2 plus 5 is 3. So 56 M to the 3rd. And then I have A to the 9 plus 17. 17 and 9 is 26. So A to the 26th power. All right, number 6. Look for all your numbers. I see a 14 and I see a 3. So 14 times 3 is 42. So I have 42. A's. A and A is down here. So I'm doing A, I'm doing 60 plus 8. Well, 60 plus 8 is 68. So I have A to the 68th power. B, so two of them. So B is going to be to the 15 plus 12. So 15 plus 12, 5 and 2 is 7, 1 and 1 is 2. So B is going to be the 27th power. And then I'm left with C. I see a 30 and a 40. So I'm doing C to the 30 plus 40. Well, 30 plus 40 is 70. So C to the 70th power. Okay, so how'd you do on those? All right, super tricky ones. I have negative 3 times 4. That is negative 12. I see E and E. So I have E to the 7th plus negative 7. Well, 7 plus negative 7 is 0. Well, E to the 0 is 1. So I don't even need to write anything down. It kind of just goes away when it's to the 0. F. I see F and F. I have F to the 1st plus 4. So that's really F to the 5th. So I have negative 12, F to the 5th, and I'm left with G to the 3rd. That travels down to my answer. Okay. Number 8, my numbers. I have 8 times 7. That's 56. Let's find J's. J, here's a J. So I'm doing J, negative 10 plus 5. Well, negative 10 plus 5 is negative 5. So I have J to the negative 5th. So I'm going to write negative 5 for a moment, but remember, we know how to simplify that. Let's look at K's. K and K. So I have K to the 7th plus negative 12. So 7 plus negative 12, I get what? That's negative 5. So I'm going to go ahead and write K to the negative 5th right now. Y to the 14th is all by itself. All right, so if we go back here, to deal with negative exponents, I cross the line and change the sign. So I'm going to do this. All of this right now is over 1. So when I do that, I'm going to write my fraction here. 56 does not move, but J to the negative 5th must travel to the bottom and become positive. K to the negative 5th must travel to the bottom and become positive. Y is positive, it stays. So here is my solution. Okay, last two. I have here negative 10 times 4 is positive 40. X and x. So x to the negative 7 plus 6. That's negative 1. So x to the negative 1. Y's, I see 4, negative 9. So I've got 4 plus negative 9. That is a negative 5. So I have y to the negative 5th. And then z. I've got a z to the 3 plus negative 3. Well, 3 plus negative 3 is 0. And z to the 0 is 1. So I need to continue here. I don't like negative, so I'm going to have to bring down x and y to the denominator because they're negative. So my final answer is going to be 40 in the numerator. And then x, it's x to the first, but we don't always write that 1. It's implied. And then y to the 5th. And then I'm going to stop on 10. We're going to come back to 10 another day. We'll address that then. All right, so if you need to come back to this video, please use this video as a guide for you to come back to if you have questions.